Hi friends, today we're talking about our linear versus nonlinear and comparing linear functions quiz. And we're starting with number 1. It says select all of the equations that represent linear functions. So here I have a couple rules. I know x cannot be in the denominator for a function to be linear. So I know that first option is going to be out. Looking at the second one, I have this in standard form. I need to write it in slope-intercept form to actually figure out if it's linear. So I'm going to go ahead and change this to 4y equals negative 6x plus 8. All I did was subtract the 6x on both sides of my equation. Now I'm going to go ahead, I need to divide both sides by 4 to get this y by itself. So now I have y equals negative 3 over 2x. I just simplified negative 6 over 4. I know that 8 divided by 4 is 2. So I have y equals negative 3 over 2x plus 2 as my final equation. That is indeed linear. So I can go ahead and I can fill in that first, or that second box. For the second equation, I'm going to distribute this 2 to both parts of the parentheses. So now I have y equals 2x plus 10. That's in slope-intercept form. That is indeed linear. So I can go ahead and fill that box in. Looking at the fourth box, I'm going to distribute the x to both parts of my parentheses. X times x gives me x squared. And x times negative 1 is negative x equal to y. This cannot be linear because I have an exponent here. So I can cross number 4 off. Number 5, same deal. I've got my exponent here. That cannot be linear, so I can cross it off. And the last one, y equals 2. If I were to plot y equals 2 on a graph, I'll just show you this briefly here. I have negative 1, negative 2, positive 1, positive 2. I would have a straight line going left to right on the y-axis of 1. That does pass the vertical line test. So those are my 3 options of linear functions for number 1. Looking at number 2, it says select the 2 situations that are best modeled with a linear function. A says Jed buys candy bars at a rate of $1.25 per candy bar. That is indeed linear. It would look like this. Y equals 1.25x. A rocket is projected from a tower. That's totally random. That is not a linear function. C, Henry is paid $7.25 per hour. I could write that as y equals 7.25x. C is indeed linear. Brooks' bank account is paying 7.2% interest compounded annually. Since it's a different amount each year, that is not going to be linear. And the last one, Ezra takes 25 pictures on the first day and 30 pictures the second day. That's random. There's no pattern there. We can't write that in slope-intercept form. That is not a function. Moving down to number 3, below are 2 partially completed tables. Complete table A such that it represents a linear function. Complete table B such that it represents a non-linear function. Okay, so for this to be linear, it needs to follow a pattern on both sides, the x and the y sides of my table. So looking here, from here to here, I am adding 3. So from here to here, I'm going to do it again. I'm going to add 3 more. I know negative 1 plus 3 is 2. And then I'm going to add 3 more here. 3 plus 2 is 5. And then I'm going to go ahead and I'm going to, on this side, it looks like I'm adding 5. And then 6 to 11, I'm adding 5. And then last but not least, when I add 5 again, 11 plus 5 gives me 16. So that's my linear table. Looking at my nonlinear table, I just can put random values in here. I don't want them to form a pattern. So I could do 0, and then I could do 2, and over here I could just do 10. Looking at number 4, Below are two partially completed tables. Add 2 points to graph A such that it represents a linear function. Add 2 points to graph B such that it represents a non-linear function. Okay, so looking at graph A, I can add 2 points. Sorry, that's not where I wanted to go. I'm going up 1 and to the left 2, so I'm going to go up 1 and to the left 1, 2, plot a point. I can also do the opposite. I can go down 1 and to the right 2. Draw my line through those points. That is a linear function. It passes a vertical line test. Looking at graph B, I've got 2 points. I want to make this nonlinear. As long as I put 2 points so that they do not pass the vertical line test, so that they're on the same vertical line as the other points, that gives me a nonlinear function. Looking at number 5, which of the following tables represents a linear function? Explain. Okay, so looking at table 1, I'm going from 2 to 4, so I'm adding 2. On my output side, my y side, I'm going from 7 to 17, I'm adding 10. And then I skip from 4 to 8. Now, technically, if I added 6 in here, so I do 2, 4, 6, 8, I'm still adding 2. And then if I added 10 more, 17 plus 10 is 27. So I'm still following a pattern if I insert those values. And an 8 and 37, that still gives me 10. I'm still adding 10 to 27, and I'm adding 2 to 6 to give me that 8. And then I go to 9. Now, technically, I'm only adding 1, but if I cut the 10 in half, if I cut 2 in half, I have 1. So if I add 8 plus 1 is 9. And then if I cut 10 in half, I would take 37 and I would add 5 to get to 42. And that does indeed give me 42. And if I add another 5, I would get 47 if I added this on here. And I would get 10, which means I'm still, from here to here, I'm still adding 2. So this table is a linear function. The table 2 is not, because we're going up by 3, then by 2, then by 4. It does not follow a pattern. Looking at number 6, Steve and Dan both drive trucks